Good morning, everybody. Are we ready for our first presentation of the day? Woo! Yeah. A quick reminder, these talks are being streamed live, and as a courtesy to our speakers and the audience, we ask that you check to make sure that your cell phones are set to silent. And if you have a question after the presentation, I will come around with the microphone, so our folks online will also be able to hear you, okay? So without further ado, please give a warm welcome to Bobby Kuzma.
All right, good morning. Everyone adequately caffeinated or otherwise chemically stimulated? Yep, okay, so we see we have got the coffee, we've got the energy drinks. I'm pretty sure I heard an Adderall bottle shaking somewhere in the background. So, yeah, I'm Bobby, I'm a hacker, in recovery. I occasionally relapse, it's a thing. So, we got pissed off at some insurance companies and decided to start a healthcare technology company here. We do prior authorization automation for clinicians, so we're having to talk to a lot of EHRs. And talking to EHRs is as much fun as you think it sounds. It turns out that those instincts that you have after a 20-year career breaking things don't go away just because you're changing path. And a lot of the documentation around the integration APIs tends to be a little sketchy, and so are the implementations. So TLDR, half of the API OAuth stacks that we looked at in our integration work turn out to leak like a sieve with regard to client IDs. There's a couple of common patterns. There's one major EHR vendor that has an awful lot of installations and an awful lot of problems with this particular thing, and we built a tool around it. So again, I'm Bobby, recovering hacker, founder of Artificer Health. We automate prior authorization. This tool came out of this day job because I kept seeing things and knowing that they weren't right and went hunting for them a little bit more deeply. So for those of you who are not in healthcare IT, you probably are not necessarily aware of what FHIR is. FHIR is the Fast Healthcare Interoperability Resource API standard. This is actually mandated by the U.S. federal government, Centers for Medicare and Medicaid Services, as the interop layer for patient data exchange and for payers to do things. And it's increasingly being mandated that FHIR-shaped APIs are going to be replacing the classic problem of fax machines for communication or the EDI at the X12 paths. So FHIR isn't fancy. It's a REST API. JSON payloads, they can support XML, but that's not preferred. And it uses OAuth for the authentication stack. There's a couple of different modes for this. There can be a back-end mode. There's also this capability called Smart on FHIR, which allows a EHR to act as the identity provider for a third-party application so that third-party application can appear inside the EHR, which is just as much fun as it sounds like. Again, these were deployed as part of a federal mandate, like literally the largest coordinated API rollout in the history of healthcare came under mandate from the COVID era on this. So it's just a REST API that's OAuth wrapped. So it has every bit of the OAuth attack surface that we've come to know and love from outside. So the mandates around this came from both a payer side mandate to make patient data available back out for third-party applications, then also for interoperability. So all of those neat little, all your personal healthcare information in one app tools all ride on top of these APIs. They are required on the EHR side to conform to a very specific functionality test suite. That's required for the Office of the National Coordinator certification process. It tests functional areas. It does not test any of the security surface. So it can be a completely botched implementation from a authentication standpoint, but still pass. It's like everything that the federal government mandates. It looks at half the problem and not the whole problem. So one of the other functionalities about this is all of these API endpoints are published in a central directory. So you get that full list from the government. What we ended up building here was a combination of a reconnaissance fingerprinting and testing methodology, looking at both the authentication side of it and then also data and bulk export. There are, call it 4 primary groupings of implementations here, some built on top of Okta, some built on top of IBM. There's Django for whatever fun reason, and then there's little one-off implementations that aren't shared across environments. The key bits of functionality around this are bulk extraction of like your patient chart for you to take it somewhere else, and then also on the payer side, similar functionality. The new and increasing mandates around being able to share information from payer to payer, so like particular to the prior authorization bits, if you've already gone through all the step therapy with one insurance company and you switch insurance companies, all that's supposed to be following along with you in the future. We're waiting for a final rule on that. But so as we were doing this, I ended up building it into a tool, call it Firebug. Yes, it's complete dad joke there on the naming convention. 22 different areas within that track 50 specific failure patterns that I've observed in the implementations that we've done. So that is available today. But the big thing that's across a lot of these, we end up with, because the spec for OAuth is kind of loose about client ID authentication between it doesn't exist versus you've got a bad secret, we end up with subtle differences that allow enumeration of client IDs. So it's a straightforward CWE 204 issue. So when we're grabbing the token, a real client ID, so same as username and password authentication. You don't want to disclose, hey, this is a valid username, just the wrong password. You want it to have the exact same response either way, so that it's just something's wrong, too bad, so sad, without providing that enumeration functionality. If there's any difference between the two, which could be as small as a single byte, then that's an enumeration weakness. Yes, it's a relatively low-grade issue, but the fact that it's relatively widespread is a little troubling. So 7 out of the 14 stacks that we tested, which covered a wide range of payer surfaces as well as individual EHRs, had this particular issue. So we looked at the reference implementation that CMS provides, major EHRs who I'm not going to name, but the big ones. We identified underlying these, in particular, Okta and IBM's IDPs are tied very tightly into that, and they have defaults that provide that lovely human-readable distinction that also allows enumeration of the client IDs. The major EHR vendor doesn't think that this is actually a vulnerability, which, depending on how you look at it, you could argue that. So, coming across the Okta defaults, unknown client gives you a bad secret, IBM Security Verify. They have very distinct error code classes across that. Django is actually good by default, but the specific implementations that we encountered overrode that. So the Django OAuth toolkit actually has sane and sensible defaults that do the proper thing, but those get overridden in the implementation side of that. Yay. Have to give some props to CMS's base implementation. It's a custom Go-based bit, and it does things properly. I was a little shocked by that. Redux, they're in the aggregation space, so they act as a middleware layer so that you don't have to do implementations across a lot of different surfaces. And then we also looked at Microsoft's healthcare data service, which implements FireShape APIs under the hood. All of that behaving nicely. So when we talk about a major EHR vendor, when we find 740-something deployments in the wild, and at a random sampling of them, 98 out of 100 displayed the same issue, that's something that's baked in. The cases where it was not an issue had WAFs in front of them that were correcting for the authentication surface. This particular vendor, their position is that the client ID is not a factor from a security standpoint. Enumeration isn't a concern, and that their defaults require sufficiently complex credentials and secrets behind that it is improbable that someone would be able to brute force that in a reasonable time frame. And their definition of reasonable time frame is up to debate, but we'll honor that. So the not vulnerable ones, CMS's implementation, straight up 401 every single time, no specific human readable or human interpretable error along with that. Ditto with Redux. They've got a mix of platform implementations. Some of it's on Auth0, some of it's on good old-fashioned Okta. Similarly, they've got exactly the same error surface there. Entra and the Azure Health Data Services, very similar. They actually filter that out at a API gateway in front of the underlying service. So the gateway is kicking things, and it's the consistent gateway that Microsoft's using across most of their stacks. So they're very specific in how they implement the non-discriminating rejection within that. A correctly configured Okta endpoint ends up being similarly not vulnerable around that. Now, the reason why this occurs is the specification leaves an edge that people can get caught on. The RFC permits a human-readable error description, and that's where this ends up flowing from. It doesn't require that the description's enumeration safe, which the best practice is you don't give away anything that you can avoid doing. The combination of defaults and the error handlers help optimize around development stuff, but not necessarily production deployments. So an attacker looking at this gets a freebie registry oracle unless there's a forcing function for uniform responses. Now, the RFC does say that the client ID is absolutely not a secret. It's the equivalent of a username. Okay, that's fine. It's a recon primitive, not a huge crown jewel kind of issue. When we get into other classes around this, the Smart on Fire capability, which lets you use the EHR login as an IDP for a third party, that provides architectural leakage around that. The actual Fire specification, the resources that are available under the hood are published so that a naive implementation and integration can see, okay, you've got X, Y, and Z, but not W, and avoid doing that. So we look at various factors around that. The issuer can potentially route you around an upstream OAuth product. The advertised key modes give clues, whether or not offline permissions are there. These tend to be things that are not built by individual payers or the EHR vendors. They're farmed out to aggregators to do that implementation, and then they wire up on the back-end side because apparently no one has resources for implementing common APIs. But EDI never dies. A lot of this gets translated into good old-fashioned X12 with lots of asterisks in it on the back end. So when you have multiple payers that are using the same aggregation vendor for supplying their compliant surface, that consolidates things down nicely, and it's pretty easy to figure out who's using what. We've built in with this some JWT fuzzing. There's 10 different attack classes that we look at, ranging from pre-auth nerdery, replay downgrade, redirect attacks. Unauthenticated doesn't really do too much here, but once you get into the developer side portals or an actual implementation surface, you start getting exposure around that. So again, we built this into a tool which, very quick command line interface, does the reconnaissance enumeration and then other bits. I'm not tempting the demo gods today, so I took the liberty of pre-recording. This is real-time on the playback. It takes about 30, 45 seconds to enumerate what resource types are available, and then we go through some of the other bits and pieces around that, including checking for the JWT-related bits, the OAuth side, different access patterns around resource release, all the other fun stuff. So something that can be wired into a CI/CD pipeline if you're on the vendor side of this, or if you're having to expose FireShape APIs. So let's see. In the course of this, we ran through recon serialization issues. There's a interesting side effect of the direct for personal care portion of the official CMS implementation. So the whole point of the direct personal care API endpoint for CMS is if you are on Medicare or Medicaid, the doctor's EHR should be able to pull in your history of claims against those services so that they can see, okay, they saw this other doctor for this other thing. A nice consolidation of care outside of the traditional healthcare interop space. That produces some interesting disproportionate blobs of data. Client enum is the big thing around that, and some of these implementations have pretty serious rate limits. The defaults that are built into the tool are respectful of all of the rate limits so that they avoid hitting anything fun. So within the overall space, we've 8 separate disclosures around gaps that were identified in specific EHR implementations. Those are all in flight right now. One of them, who got back very quickly, I do have to give them credit on that, had pretty good reasoning around why they don't feel that that's a vulnerability. We're waiting on the other 7. This is something, feel free to replicate it, run it against any fire-shaped endpoints that your organization happens to be running, all of that other fun stuff. The implementation across this is pretty interesting. Again, when you get a mandate around conformance for an API that doesn't include actual security-related stuff, you end up getting great conformance on the data side, but not so much on the things that potentially matter. So, yay government. All right. Questions? No? No questions? Excellent. Anyone want to gripe about their healthcare experiences recently? So again, this whole thing came out of me starting a prior authorization automation company. I got tired of my doctors complaining that they were in the office until midnight filling out this stuff, and my 14-year-old waiting 3 months to get approval for a migraine med that actually worked. So, I decided that this problem was something important enough for me to tackle, and I keep finding weird stuff because none of this is cleanly implemented. Everyone does their own thing on these APIs. Integration is hard, and doing it from scratch in a lot of cases is also an interesting challenge. So happy to chat afterward if there's anyone has any stories to share or other questions. But thank you for coming out and taking a look, and enjoy the rest of your show.
You mentioned a correctly configured Okta. Thing is, how often do you come across incorrectly configured Okta? I can guess, but I want to throw you something.
Well, I found more hen's teeth than I found correctly configured Oktas,
All right.
at
Thanks,
least
man.
in the wild. Well, I'm sorry for adding something to your work queue, but I'm glad that something useful came from it.
When it comes around, I'm either getting fired or promoted.
Okay. Well, if you get promoted, yep.
Even when I'm like this? Yeah? Okay. I'm a little tall and this microphone is a little short, so gotta make sure.
The door is closed.
Yeah, well, it might open and close during the talk, but I'll try to speak up. Yeah, I'm ready.
Welcome back, everyone. Quick reminder, please keep your phone on silent as respect to our participants and our talkers. And this presentation is also streamed live, so if you have any questions at the end, I will come around with the microphone so the people online can hear you. So without further ado, please welcome Moshe Bernstein.
Good pronunciation. Hi, guys and girls. These are the brave souls who made it to the last day of the conference. Congrats. Welcome to Agents of Chaos, a systemic approach to finding GCP 0 days. By show of hands, who here thinks they have what it takes to hack into Google? No one? Oh, okay, we have one. Have you already ever hacked into Google? Okay, well, hopefully by the end of today, many more of you will have your hands up next time somebody asks you that question. My name is Moshe Bernstein, and I'm a senior security researcher at Tenable with over 10 years of experience in cybersecurity. I'm also a bug hunter for the Google VRP, and I'm currently ranked number 10 in the all-time Google VRP leaderboard for US researchers. In my spare time, I really enjoy traveling and seeing new places. I've visited 33 countries and 23 US states so far. This is what we're going to go over today. We'll start with a quick introduction where I'll introduce you to the concept of GCP service agents. They're special identities in the cloud that can be a great opportunity for us bug hunters. I'll then share with you my simple, repeatable methodology that I use to find privilege escalation bugs in the cloud. We will then work through that methodology in 2 case studies. The first, cloud monitoring, is where a read-only user could run anything at the click of a button. And the second, event arc, is where loose authorization checks led to full project takeover. I will then share with you a tool that I developed called Agent Map that can help you become the hero and find these kinds of vulnerabilities yourself. Finally, some key takeaways and a personal note. So what actually are GCP service agents? If you don't know, GCP service agents are Google-managed service accounts in the cloud. They're also called the per product, per project service accounts, or P4SA for short. They're created and inserted automatically into your cloud project when you use services. And why is that? They're actually responsible for orchestrating the background tasks and cross-service communication in the cloud. So what does that actually look like? Let's say we have a GCP user who has access to a service called Google Cloud Run. If you're not familiar with Cloud Run, it's a fully managed, containerized application service. For Cloud Run to actually work properly, it needs access to some underlying dependencies of other Google services. It needs access to artifact registry, networking, storage, and compute. Behind the scenes, there is an identity that manages this dependency. It's called a service agent. The service agent has permissions for all of these services on the left. Your right, sorry. And it's the one who's responsible for orchestrating them so that Cloud Run can work properly. So why are these service agents dangerous or a great opportunity for bug hunters? Well, they're often high privilege since they need access to the services in order to work. They're also hidden. If you want to see which service agents are associated with your project, you actually have to click a special button in the UI. You don't see them by default. They're interconnected across multiple services, which is where we usually see cracks in the cloud. And they're a key lifecycle component of how a service works. And finally, and most importantly in my opinion, exploiting a service agent doesn't rely on user error or misconfiguration as so many attack vectors in the cloud normally do. So let's see this visually as well. We have the same graph from earlier, but this time the user is compromised in some way. They either have malicious intent, or they lost their identity, or they uploaded it to GitHub or something. If the user could use their access to Cloud Run to actually gain access to the service agent identity, they would be able to escalate their privileges to all of these services on the left, on the right as well. This is called a privilege escalation vulnerability in the cloud. A user who doesn't have permissions to a specific service is able to gain permissions to that service. Makes sense. So now I want to share with you my methodology for finding these kinds of vulnerabilities. It's a 4-step, simple process that you can use across all of the cloud to find these kinds of bugs. The first step is to pick your target. The attack surface for the cloud is vast, and it can be very intimidating. But I urge you to search for interesting permissions. Google uploads all of the permissions for every service to the Google Cloud documentation. You can search for interesting permissions of roles associated with the service or of the service agent itself. You can also try looking at underexplored services. The most popular services that we all know probably have a lot of eyes on them, like developers or security engineers or maybe other researchers. But if you look at the underexplored services that not many people know about, you're more likely to find some bugs. Additionally, I'm a really big believer that the more you use the product and the console and the cloud, and the more you research it, leads will fall into your lap just on their own. This is true. Once you've picked your target, step number 2 is to understand the service as deeply as possible. That means use the UI as much as you can. Click every button, change every form, read the detailed documentation that Google uploads to the Google Cloud documentation, and monitor the network requests in the background to actually see what is running. If you understand the service very deeply, you may find some primitives that are just features of the service that can be used in a future vulnerability. Once you have these primitives, step number 3 is to think like an attacker. If I have these features or primitives, what is the missing piece that I need in order to make these a vulnerability? If I had malicious intent, what could I actually gain from this environment? Once you understand that, step number 4 is to escalate your privileges. That means leverage the findings from step 2 and 3 to expand your access. Remember, in the cloud, if you're able to access a service that you don't have permissions for, that's a PE vulnerability. Feel free to take a picture of this if you want. As you can see, I also assigned handy icons for each of the steps so that you can follow along through the methodology as we work through the case studies. So let's start with case study number 1, which is cloud monitoring. Cloud monitoring is part of the Google Cloud Observability Suite. That means it runs alongside Cloud Logging, Cloud Trace, and all of these services which are intended to give you visibility into what your cloud looks like. It automatically monitors GCP services as you're using them, and you can visualize the status of your services using dashboards. Google gives you some of these dashboards out of the box, but you can also create your own if you want. Additionally, you can create proactive alerts and notifications to test your services and let you know if something goes wrong. So why did I choose cloud monitoring as a target? Well, it's a part of the core infrastructure of the cloud, and it also has access to data from many other services. As a bug hunter, this led me to believe that if I could find a vulnerability here, it would be a really impactful one. Additionally, I don't know if this is relevant to anyone else here, but I found vulnerabilities there in the past, so that's always a good hunch. So cloud monitoring and observability has a really wide scope and tons of features. We're only going to focus on one today, which is called uptime checks. Uptime checks are a way to check the status of your services periodically and just monitor them and let you know if something changes or something goes wrong. You could also potentially notify an administrator or something if that happens. I'm a true believer that in order to understand the service, you need to use the UI, as I said. So let's create an uptime check together so that we can understand exactly how it works. Creating an uptime check is a 4-stage process, and it starts with choosing your target. This is what the uptime check will actually be testing against. We can control the protocol for the uptime check, which is currently set to HTTP, but it can be also set to HTTPS. We can control what the type of the resource will be. In this case, it's a URL, but we can make it into an internal IP, Kubernetes, Cloud Run, or any number of things. Since we're using URL, we also fully control the destination. We can control what the host name will be and the path. At the bottom, we have more target options. When we click that, we actually see that we get full control over the HTTP request that is sent by the uptime check. We can control the method, which is GET, but if we change that to POST, we control the body too. We can also add any custom headers that we want, or authentication. The default is basic authentication, but Google offers us the ability to use service agent authentication. Remember service agents? Here you can see that Google hardcoded the monitoring notification service agent. We can tell it's a service agent because its email has @gcp-sa. Remember that. This is what a service agent's email looks like. A service account that's created by the users of the project will have a completely different email. We'll skip response validation and alert notification since those are optional stages and jump straight to the final stage, the review. Here we can choose a name for our uptime check, but Google also suggests that we test it before we actually create it, just to make sure that everything works properly. Makes sense. So what primitives do we actually have just by using the features of this service? We have an arbitrary target, full request control, and service agent authentication. At this point, we're only missing one piece of the puzzle to make these primitives turn into a vulnerability. So now it's time to think like an attacker. Who can actually create these uptime checks? When I was looking at the roles associated with uptime checks, I saw this extremely weak monitoring uptime check configuration viewer role. The only permissions it has are get and list for uptime check configurations. When I gave myself this role, I couldn't click the create uptime check button. I didn't have the proper permissions. It's grayed out. But that's just a button. What if I browse to the create URL directly? Well, here I'm browsing to /monitoring/uptime/create. When I browse there, I get the expected you need additional access page telling me I don't have the proper permissions. But it seems there's some kind of race condition here behind the scenes, because all I needed to do was wait for 1 second, and then magically the creation UI opened anyway. Pretty cool. This is what it looks like in real time. I'm opening a new tab, typing in the URL, and pressing enter. You'll see you need additional access for maybe a second, and then it's going to disappear and show the creation UI just like magic. This is me recreating that SpongeBob GIF. OK, so we can access the creation UI as a user who has read-only permissions and can't actually create an uptime check. Well, what does this give us? If I try to create an uptime check, Google will verify my permissions and deny me the ability to create one. But remember that Google suggested we test our uptime check before creating it? What happens if I click test? When I click test, I actually get a response from my server, meaning I'm able, as a read-only user, to configure whatever uptime check I want and then test it. So now we have the full picture. Arbitrary target, full request control, service agent authentication, and the final missing piece of the puzzle, weak user invocation. Now that's a vulnerability. So how can we actually exploit this? Well, let's say we have this weak uptime check viewer role. In the same project, there is an authenticated Cloud Run which can update people's permissions. The creators of this Cloud Run knew it was a very powerful tool, so they locked it behind strict authorization checks. If the uptime check viewer were to try to give themselves elevated privileges by calling this Cloud Run, they would get permission denied, since they don't have the proper permissions, obviously. But what if this uptime check viewer were to open the UI for uptime checks and then test an uptime check which authenticates as a service agent, which invokes the Cloud Run? The service agent actually has permissions to invoke Cloud Runs, so this will work and grant the uptime check viewer full project editor, the most powerful role in a project. If this works, it would be pretty cool, right? Let's see. OK, so here we can see that in the victims project, the attacker only has the read-only configuration viewer role. There is also this authenticated Cloud Run, which the user, or the attacker in this case, can't actually run themselves. They also can't click the create uptime check button because they don't have the permissions. But if they browse to the URL, as we saw, it'll show you need additional access and then immediately go away. They can then target the authenticated Cloud Run that they don't have access to and make sure to use service agent authentication. Since they have full control over the request, they can change the method to post and put their own email and the role that they want in the body. The attacker then, all they need to do is to test the uptime check, which will actually invoke the Cloud Run and get it to 100 OK. When we go back to the IAM permissions, we'll see that the attacker now has the editor role in the project. So in this case, thanks. In this case, a read-only viewer that had get and list permissions for some arbitrary cloud monitoring feature is able to reach full project editor. This is the disclosure timeline for this vulnerability. As you might notice, Google paid me $9,000 bounty for this vulnerability. Even though it might seem simple, Google values these types of privilege escalation vulnerabilities in the cloud extremely highly. Now we'll move on to our second case study, which is EventArc. EventArc is a fully managed platform for building event-driven pipelines between GCP services. If that doesn't make sense to you, just give it a second. It's offered in 2 editions, Standard and Advanced, and it supports over 130 event providers and it can deliver events to Cloud Run, GKE, workflows, and others. So why did I actually choose EventArc? Well, it's a powerful service that connects many other services. As we saw, when services are connected to each other, oftentimes there are cracks there. Additionally, as powerful as it is, I don't think a lot of people are familiar with EventArc, which led me to believe that I might find more bugs there. And finally, when looking at the documentation for EventArc, I saw that the service agent associated with it is extremely privileged. So if I could exploit it some way, that would be a great vulnerability. So this is what EventArc Advanced looks like. On the left, we can see that we have the providers or the sources for the events. Those events then get fed into something called a bus. That bus then feeds the events into something called a pipeline, which targets one of these destinations. If it still doesn't make sense, give it another second. When would I want to use a service like EventArc? This is from the Google Cloud blog. Let's say we have a commerce platform, and we want events to propagate between the different parts of our platform. We want an event to go from commerce to finance, and from finance to logistics, and from logistics onwards. This is when you would use a service like EventArc. You take events and you propagate them through other services. Again, let's use the UI to create and use this service so that we understand exactly how it works. First, we saw that there's a bus, so let's create a bus. A bus is very simple. You just choose a name, region, login configuration, dry details like that. A bus has no logic within it. It's just a sink for events. All of the logic is actually in the pipelines. So let's create a pipeline. As you can see, creating a pipeline is a little bit more complex. We have 4 stages, and it also starts with dry details like the name and the region. The second stage is the enrollment stage. This is when you actually connect between a pipeline and a bus. Here we're enrolling this pipeline to the bus that we created earlier. There's also this matching expression, which will decide which events that arrive in the bus are actually going to trigger the pipeline. In this case, we're leaving it as true so that any event that arrives in the bus will trigger the pipeline. We'll skip event mediation since it's optional and jump straight to destination. This is what the target of the pipeline will be. In this case, it's currently set to be an HTTP endpoint, but we can also change that to other things, like another EventArc Advanced bus if we want these events to keep flowing, or workflows, PubSub, or our favorite, Cloud Run. Since we're using an HTTP endpoint, we can also control the destination, or enable authentication. When we enable the authentication, we see that we have full control over what the header will look like. We can use an OAuth token, but we can also use an OIDC token. And we can control which service account will be the one who is authenticating. When I go to choose which service account I want to use, we can see that Google are hard coding it to be a service account that is created by humans and not by Google. Remember, a service agent needs to be at GCP-SA. And here, it's at the name of my project. So this is not going to be a service agent. It's going to be a service account. So what primitives do we have just by using the features of EventArc? Arbitrary target, full request control, and service account authentication. At this point, your spidey senses should already be tingling and telling you that we're only missing one piece of the puzzle to make this a vulnerability. Now it's time to think like an attacker. So who can actually act as? If you don't know, in Google Cloud, in order to use service accounts, you need a special permission called IAM service accounts act as. If you don't have this permission, you can't actually use service accounts. But when we look at the roles for EventArc, specifically the administrator role, which is the most powerful of them, we don't see this IAM service accounts act as permission in their permissions. When I gave myself this role, I was able to use EventArc as much as I wanted. So we understand that we actually don't need IAM service accounts act as to use EventArc. But what gives? We saw that we could choose a service account to act as. So who is actually acting as this service account? Well, if we look at the permissions for this service agent, we actually do see the IAM service accounts act as permission, alongside the get access token and get OpenID token permissions. This fully correlates to what we saw in the UI, where we could choose an arbitrary service account and choose if we wanted to use an OAuth token or an OIDC token. This is actually a very simplified version of the permissions for this service agent. It's so powerful that I couldn't even fit all its permissions on the slide. Now, seeing how powerful this service agent is, and seeing as it's the one who's choosing which service account to act as, what if I could trick the agent into acting as itself? That would be a pretty cool escalation of privilege. But When I was going to choose a service account, remember, Google validated that I'm not using a service agent by hard-coding the email here. But this is just front-end validation. What if I actually change the request in the backend? So that's what I did. I changed the request in the backend to actually put the service agent's email there instead. And guess what? I could actually create a pipeline which authenticates as the very powerful EventArc service agent. So now we have the full picture again. Arbitrary target, full request control, service agent authentication, and the final piece of the puzzle, do you remember? Weak user invocation. Now that's a vulnerability. Ready to hack the mainframe? So how can we actually exploit this? Well, let's say we have an EventArc user. In their own project, they create a malicious HTTP server or Cloud Run which exfiltrates any headers that it gets. The EventArc user could then create and trigger a pipeline with service agent authentication using the backend trick I just told you. That EventArc pipeline would then authenticate using the service agent to the attacker's malicious server. The server would then exfiltrate the token back to the EventArc user and give them essentially full control over the project. I think you can see where I'm going with this. So here we can see that in the victim's project, all the attacker has is the EventArc roles. In their own project, they create a malicious HTTP server which logs all of the authorization tokens. In this case, there is already a bus that exists in the project, so they don't need to create a bus, but they will go ahead and create a pipeline. They'll give an arbitrary name, choose a region, and login configuration. This doesn't matter very much. But next, they will enroll this pipeline to the bus that already exists. They'll use the matching expression true so that any event that arrives in the bus will trigger the pipeline. They can then target their malicious HTTP server and enable authentication. When they enable authentication, they have to use a placeholder service account here. But in the back end, using a search and replace, we can actually replace that with the email of the service agent. Now, all the attacker needs to do is create the pipeline. Once the pipeline is created, we can actually see that the service agent is the one who's being used for authentication. So all that remains is for the attacker to just send a message to the bus, which will invoke this pipeline, which will trigger the service agent to authenticate to the attacker's malicious server. And the attacker gets the service agent's token. Once again, from a pretty weak role to full project takeover. This is the disclosure timeline for the second vulnerability. As you can see, Google awarded me a bounty of $12,000 for this vulnerability. So we were able to use a fully repeatable methodology across different services to find privilege escalation bugs that are worth tens of thousands of dollars. And now I want to share with you a tool that will help you do this too. It's called Agent Map. If we look back at this graph from the start of the presentation, what can we actually understand about the nature of the cloud by looking at the relationship between the service agent, and the dependencies? By looking at the permissions that a service agent has, we can understand the interconnected nature of GCP services. So that's why I developed Agent Map. It's a tool that maps all of the service agent permissions by scraping the Google Cloud documentation. It then visualizes the connectivity between the services using those permissions, and it will also highlight dangerous permissions and privilege escalation paths so that you can generate further leads for more privilege escalation vulnerability research. So let's see Agent Map. I'm going to go back to my screen. Let's hope this works. Don't worry if you didn't have time to scan the QR, I'll show it again in the end. Here we can see that in our data set, we are currently monitoring 153 services, 200 agents, 133 dependencies, and over 4,000 permissions. We can also filter by the service, the role, or the dependency. Here in the center, we have our graph. Currently, it's just showing all of the services that we're monitoring. But if we click on one of them, like Apogee, we'll see that it has one service agent associated with it, the Apogee service agent. If we click on the service agent, we can actually see all of the dependencies of Apogee based on the service agent's permissions. Here on the right, you can see all of the details of this service agent role, we can see that agent map is highlighting to us what the vulnerable permissions are, and it's also showing us what services it can reach. We can click on these to get more details. At the bottom, we have a full list of the entire permissions, and we can filter that based on escalation, write, or read. So now I want to use agent map to work through our 2 case studies. We'll start with monitoring. Oh, sorry. Let's clear first. And event arc. OK. So if we click on monitoring, we actually see the monitoring notification service agent, which we saw in our vulnerability. When we click on it, we can see that one of its dependencies is Cloud Run. When we scroll down, we can actually see the run routes invoke permission, which allowed our vulnerability to be possible. If we wanted, we could copy this permission, paste it up here in the search, and see a list of all of the service agents who actually have this permission. It can help us find more vulnerabilities just like that one. Now, if we click on event arc, we see the event arc service agent, which was also relevant to our second case study. When we click on that one, we can actually see that some of these services are shared between the 2 services. The dependencies are shared. This gives us some insight into how the cloud is built. At Tenable, we like to call this Jenga, where services are built upon services. If we click on event arc, same thing. We'll see that agent map is actually highlighting to us that 4 of this agent's permissions are escalation relevant. When we scroll down and filter by escalation, we see the 3 IAM permissions which enabled our vulnerability. Pretty cool. So you can use agent map. It's very easy, and it's going to be open source, so feel free to check it out on GitHub. This is what agent map actually looked like when I first developed it, so thanks to Claude for the glow up. Makes it look much better. So what are our takeaways from today? Well, first of all, there's an invisible threat in the cloud, and it's called service agents. These agents operate silently in the background, and they're usually highly privileged, which makes them a golden opportunity for us bug hunters. The second takeaway is that the cloud is built on recurring patterns. These recurring patterns allow us to use repeatable methodologies to find similar kinds of bugs worth tens of thousands of dollars across completely different services. And finally, you can use a tool like Agent Map to visualize the interconnected nature of the services in the cloud and find future vulnerability leads. Now, I just want to share a quick personal note on AI responsibility. As a bug hunter, it can be extremely tempting in the modern era of AI to just ask Claude to find a vulnerability for you and report whatever it finds. We're increasingly seeing, though, that VRP and triage teams and bug bounty programs are getting swamped with unverified AI slop reports. These teams are verifying manually every single one of these reports, and it's taking really precious time away from real researchers like you and me who have real methodologies like the one I shared with you today. So you should be using AI in your vulnerability research. It's an amazing tool. But remember to verify everything you submit and that the responsibility for these submissions is truly your own. Now it's your turn. Go and find some 0 days. I hope next time I ask the question of who's ready to hack into Google, more people will raise their hands. If you find something cool using my methodology, please feel free to reach out to me or tag me. I'd love to hear about it. And you can check out Agent Map for yourself here in GitHub. Thank you so much. I think I have like maybe 1 or 2 minutes for questions. We got one right here in the center. I'll leave this up on the screen.
I noticed when I talk on Monday, the presenter was telling me that a lot of the logs for GCP are actually turned off.
Wait, sorry, can you repeat it a little slower with the mic?
I noticed on Monday there was a talk, especially about logging for GCP, where they were saying that a lot of the logs, especially like the STS log and the IAM credential logging, are turned off by default, and then a lot of Google's logs are actually behind a paywall. This escalation you did, especially you would expect like the IAM credential logs, it would show, you know, if you were drop your logs, it would show that this was up, you know, this person's credentials or privilege was escalated. But without those logs, you wouldn't see that if you were monitoring or doing any type of actual, dumping it off to SIM or doing something. You wouldn't see any of this, what you did in the logs or alerts, right?
Well, I mean, it really depends how you configure them. But ultimately, the point of showing you that vulnerability was not to like make you worried that you need to defend against it, but more to give you kind of like a look behind the scenes at how service agents can be used by bug hunters to find vulnerabilities. And ultimately, if people like me and maybe you can find these vulnerabilities and report them to Google, then it will be their responsibility and you don't have to worry about it at all. Any more questions? Okay, thank you so much.
All right, quick reminder to please keep your phone on silent as a respect to our participants and our speakers. And this talk will be recorded live. So if you have any questions afterwards, I will come around with the microphone so our folks online can also hear you. Please welcome Raj from Unbound Security.
Hey, thanks everyone for coming. It's day 3 and you're not in a poll, so I'll make your time worthwhile for sure. So this talk is about what bounds your coding agent, and it has evolved significantly from how things used to be from Devin's initial demo from, I think, late 2024 to where things are today with Claude, right? Like pretty much nobody's writing code by hand anymore. So just quick show of hands who are using Claude Code day in and day out today. Everybody. GitHub Copilot fans, anyone? Okay, a couple of them, mostly because your employer is forcing it, right? Yes. Codex has become more popular, so that's good. Gemini CLI, anti-gravity, no. Okay, so that's good. So a lot of what we're talking today is going to be using Claude Code terminology, but honestly, it just applies everywhere, and I will bring up things as I see relevant for Cursor or Copilot as well. So yeah, I'll leave significant amount of questions towards the end as well, so I have time for questions. So quick intro, I'm Raj. I'm the founder and CEO of Unbound. As a vendor, I'm obligated to tell you that the sky is falling, but I'll try to keep it relatively lighter. It's pretty balanced, and I've based it out of research. So prior to this, I was doing security at Palo Alto Networks, Imperva, and a bunch of other companies. So we're based out of San Francisco. But for the purpose of most of this presentation, it's going to be based on grounded research from Axwell or even like most of Anthropic and OpenAI documentation, right? So why are we here? Obviously, adoption for AI in general and coding agents in particular moved much faster than where the controls started out to be. And there's clearly much good news in 2026 than it used to be as of last year, right? Like, so there was a lot of worry around things like prompt injection, rug pull attack, context poisoning, and so on that was in place. The fact remains that we are significantly getting better at it as an industry. even without a lot of controls overlaid. So you don't need like 40 different tools to go stop you from prompt injection today. Models are getting better, the harness are getting better, and we're going to talk about how that's getting there as well. The second, which has become more prevalent after the Hugging Face incident, and now OpenAI joined the fences as well, claiming, hey, we also are able to hack. So that's the agentic overreach, as we call, which is you ask agent to do X, it's just so proactive that it chooses to do X plus Y plus Z. It is a much harder problem to fix because it is not a third party trying to poison your tool or somebody trying to confuse the LLM or the coding agent into doing something that it shouldn't. It's basically agents just took some shortcuts, very similar to how humans do, and that is exactly what the models are programmed for. So that is why it is even harder to fix at a global level. And we'll talk about some of the harnesses and safeguards that we can take on top of it. The last one is user level safeguards. So agents are agents, so they get crafty. Users are even more crafty. Like this is particularly relevant as it moves beyond like just developer community. With Claude Code, you could pretty much do anything today. Claude Cowork, you could pretty much do anything today. And it is available in most organizations to every knowledge worker at this point. So what that means is users are going to push LLMs into doing things that are not exactly safe. And this will just keep happening because they don't know what they're signing up for. So we'll talk about the user vector as well as we move further in the slides. So a lot of this is going to be just primer. This is anatomy of any agent. So you have the prompt and you have the model that is responding to the prompt. This is ChatGPT as we know in 2023, right? Like what really changed was the execution layer. So it pretty much gave LLM wings, right? Like, so, hey, you don't just come back with some browser response and then I copy paste that code. It's not like glorified Stack Overflow anymore, wherein it is able to do actions on my behalf. And when we say actions, the execution piece, it happens in a few ways. Like obviously, you have MCPs, which came about 2025, got popular at least in early 2025, where it's like, hey, it's an API adoption layer where LLMs have enough context to say, oh, go call this API with this signature and this API key, and then it can go do those actions for you. So you can go query the web, you can go do actions, you can do emails and so on. Great. And then the whole thing that makes it agentic is that now it also acts on the feedback. So I not only just ask, hey, how do I troubleshoot this issue? And then it tries to do something, build some code. It'll also execute the code, see if there are any errors, and then go back and fix it. So that's the feedback layer that comes, right? So this is pretty much how any agent operates today. Coding agents are not that different, so to speak. So there's obviously the model component to it. Models are getting more and more powerful, so they are also getting more and more clearer about what they're telling the execution layer to do. And what governs a good coding agent as to a bad one is just how well the execution layer and the feedback layer operates. So how are you able to parse through the feedback? Are you just looking for errors? Are you looking for qualitative outputs? And then how do you feed it back to the next iteration for the model and the loop and the execute to continue? So this is just the anatomy of how any agent operates today. And even if you're building, let's say, a consumer-facing agent, this is pretty much the loop that you're operating on. A lot of agents that are out there today don't have good feedback loops, and that's what differentiates, I believe, Claude Code and Codex from some random third-party chat-based agent that you'll see in any other website. So there is obviously the layer, which is the POS layer that recently got introduced. Earlier, if you had to do a POS layer or be in a barrier between model and the tool use, you had to use like an LLM gateway and have the LLM gateway scrub out some responses and do things on top of it, parse it, and so on. So the POS layer became very popular as people needed tighter harnesses. So everything we're going to talk about today is going to be at the POS layer, and there are different ways to POS. So all we are trying to do is get in between the model and the execution layer to just verify that, hey, does this make sense or not with what you're trying to do and what was asked for at the prompt level. And remember, since it's a feedback loop, the prompt itself need not exactly be what you asked for. This could be the fourth iteration of the prompt, wherein the feedback that you got from the previous run is pretty much what is the prompt. So it becomes important to quantify what was the goal and the original user intent, and then where we are today. And every hack that you see on LinkedIn about like, hey, you could do a slash loop and goal and everything, this are all like, it's just loops on top of this. So you're manually changing how the feedback loop operates by and large. So you're just saying, hey, this is the goal, go run your autonomous loops on top. Or this is my goal and this is how I want you to think through like, the process of it, and then don't go execute and then execute when I say. It's all like just interventions in one of the four. From a security perspective, everything that we're going to talk about and do today is going to be at the POS layer. How do you stop from the model saying what it's saying to it actually doing what it is supposed to or not supposed to do, right? And including prompt injection, this is just where everybody's starting at. This is from, again, Simon Wilson. This is 2025, became very popular, the lethal trifecta, as he called it, right? Like, so it's the combination of untrusted input, private data, and the ability to communicate externally. So the thesis behind Simon Wilson's paper originally was that, hey, you cut off one of these legs, then your execution layer becomes significantly more secure, right? Like, so it is, and that's why you see a lot of what even native frontier models capability today is modeled around this trifecta. So it's like, hey, do you trust this folder before you start a session on Claude? And then like, yeah, I trust this folder. Okay, so that's like the relatively trusted input there. And then can this run dangerously skip permissions and so on? So this is very good from the perspective of, hey, how do I make sure it is not exfiltrating sensitive data? So the core of the Venn diagram remains on exfiltration. So, okay, I have untrusted input trying to steal data from me, and then I have an external communication methodology to send that data out, which is great. And 95% of all exploits go after here. And if I'm a malicious actor trying to do prompt injection to get my Claude into leaking environment variables, this is what I would follow, right? Like, so it's just and that is why cutting off one of the three legs makes a lot of sense. You drop external communication, it's okay, they do what they do, maybe it'll sit in an agent and CrowdStrike or EDR will eventually catch it and so on. So it's just the different permutations and combination. So this works for secret prevention. Where it falls apart slightly is around agentic overreach, and we'll talk about that. But this has been modeled very well, and the best solution for it, in our opinion today, is the auto mode. Both Claude and Cursor have this today, and there are adoptions of this coming up to Codex. GitHub Copilot does not, like you're pretty much on YOLO mode and so on. Like for primer, what auto mode really is, so remember the POS layer that we spoke about, it adds a default LLM-centric prompt-oriented POS layer. So all it does is, it has the idea of, hey, this is the prompt that was asked for, this is the tool use action, and this is the structure of where it came from. So it has like a defined hierarchy of the prompt itself. Hey, this is MCP context, this is coming from a third-party skill, and this is what the user prompt looked like. And each of them have different trusted options to make sure that you are not able to, like, sneak in a prompt injection through a relatively malicious skill. If you use like frontier, like top tier Opus or even Fable models today, you would see that it's extremely hard to do a prompt injection attack today. And we know it because we try to do demos of these all the time, and it just got significantly harder with at least the top tier frontier models. Like with DeepSeek and many of the other ones we see fairly often, where we are able to demonstrate examples of that. It's easy to confuse it through tool call poisoning, and even like if I just give it a malicious scale, it would largely follow instructions. It'll move environment variable credentials without you asking for it. So that's pretty good, which is like 99.2%, right? Like I think that's more than what we could accept. We live in a world where now security is becoming more and more non-deterministic. So if that's a good enough number to live with. The false negative is the issue that we run into. This is from the Axo study again. The DOI for it is over here, wherein we talk about like 17% false negatives based on that independent study. A lot of it really points to what we call as, hey, how do I know that this is actually not what you intended, right? Like, so your user prompt typically comes to be like, hey, okay, go fix this issue, go troubleshoot for me, or go build this large one-off single-shot prompted command. So what that really means is, in a lot of situations, the agent is actually making a decision about what needs to happen. So this idea that, okay, I will go look into the user prompt, seize the source of truth, and then stop any action that doesn't align with what you asked for, is kind of, the whole argument falls apart there, because all I asked for it is to troubleshoot us the issue. So does it mean restarting my services? Maybe. Does it mean going and cleaning up like cache files? Probably. Does it mean going and cleaning up another folder that is adjacent to my cache file? Maybe, maybe not, right? Like, so this exercise around looking at user prompt and doing things around it falls apart. And that is why this is a much harder problem to solve. And I'm like, any vendor or anything of that sort that says like, hey, we can detect prompt injection, is kind of where Opus is right now, right? Like Anthropic can also detect prompt injection, and many of the frontier model suites can detect prompt injection. This is harder to solve, and where it comes to is, okay, how far do you go when you determine the difference between what you asked for and did the agent actually do an overreach or not? And this is really an unsolved problem today. Like core frontier research is also trying to solve the same problem. What we can do at the interim is basically go after like a couple of ways to do this. And these are just documented evidences. I think it's pretty clear at this point where things are at, particularly after Hugging Face incident. Versions of this happened even prior, like Replit. And again, July 2025 models were completely in a different kind of a place altogether. But even in many localized smaller scenarios, we see this happen, databases going for a toss, things like, cookie injections happening in several scenarios to just capture browser intent. We actually saw one instance where Claude basically tried to get a JWT token by spinning up a browser session, logging in as the user, getting that JWT token and using it at the API. These are fairly common scenarios that we see within our base. So what we can do at the interim, while we are still trying to, hey, is this possible at all to prevent agentic overreach? Maybe not. So the gap really between is, okay, what is the space that we can look at, and how do we block the space, right? Like, so what I'm calling is the authority, autonomy, and the ability to do reversibility. So authority is really where it can go to, right? Like, so sandboxing is a relatively legitimate way to stop some of these from happening. Yes, there are instances of sandbox escapes and so on. And you could prevent a lot of the sandbox escapes through the hooks control as well, as we will talk about. Like, as governed as we think sandboxes are, they're particularly the local ones, right? Like, there are people that use Obstack and Docker-based instances that is within their own machine. So it's like, okay, my laptop at least is protected so it doesn't accidentally wipe out my D drive, kind of the scenario that we saw. That is the least secure in a way because it can escape the sandbox boundaries very easily. Like the host communication protocols the commands are very easy to just go through the host barrier to get through. So what you can prevent some of that through hooks. A relatively more secure version is cloud sandboxes. Like, if you just have like a Stripe or the equivalent of it, Sprite or the equivalent of it, that works out okay. And these are like destructible sandboxes. The problem then comes into the action layer, right? Like, so you do want the agent to eventually do something. And if you cut off all the legs, like, where is it going to go and what is it going to do, right? Like, so file system is probably the easiest. If it's a sandbox, you don't care about anything that's going on in the file system. Egress is the next step. So it's like, hey, how do I make sure, like, where it is all proxied through some secure layer, and then I know that the egress addresses are trusted. I can put like a Cloudflare example on it, and then say like, hey, okay, this is just what I'm going through. So there are controls that we'll see open source repositories as well, and something about what we do at Unbound too, as we go further into the authority part of it. So autonomy is the most trickiest part, right? Like, so, and we are now pretty much at a position where nobody is doing, oh yeah, I'm just going to press yes for every command that it's asking. It's almost like the Vista version of, hey, do you want to do this or not? So how far do you go to give autonomy, but also like, tire people out from what they're doing? And when this comes to non-developers on co-work, how does this scale? Like, you give them a very complex bash command with 2 pipes and 4 awk and sed, like, they're not going to understand what they're seeing, and they're just going to press yes by default, which is, we are all guilty of it ourselves, right? Like, so where does it go from getting there to the, being able to say, okay, everything is okay. So auto mode is that in between, right? Like, okay, yeah, just have another additional prompt, go through this, does it make sense or not, and then it goes through. The second layer really comes to, okay, so you have a cloud sandbox, and then you have the auto mode, and then where do you go in terms of autonomy from there? Like, let's say it is an MCP action. Let's say it is something that is beyond just the file system. Where do you go from it, right? Like, so that is where a lot more of the hygiene and the user process comes into play. So MCPs needs to be like, provisioned with least amount of privileges and so on. So we'll talk about some of that as well. And last is the reversibility. So anything that is important and urgent, you want to have backups for that. And yes, as much as AI will tell you that, hey, this is not recoverable from a backup, we've seen instances that it always is if you have the right practices. So this is the seatbelt and bubble wrap, as we call it, the analogy, right? Like, so, and these are all available even within Anthropic's GitHub resources. Like, it has like the deny rules, the allow rules, and whether you want to have sandbox mode enabled by default or not. And Claude even now has native cloud sandboxes too as a part of the plans. So we'll share about resources at the end of this as well. Like, we'll have like GitHub repos that you could point to. This one is the most relevant one because it has a more conservative and relatively aggressive allow default deny rules. So, and if you do enforce this via MDM, like, it actually supersedes any of the local changes that the user is trying to make. So even if it's on your home directory, even if it's on a project folder, what you have at the MDM settings level, which would go into like, /library preferences kind of folders, and they're not able to, even if they have admin access, there are managed settings ways to go reset it. That is a good way to do that as an in-between to basically get a good baseline from there. So it's the auto mode equivalent of cutting off legs in the sense of don't have way too much autonomy, but at the same time, don't ask permissions for certain things. So if the agent is supposed to be doing XYZ actions, it asks permissions for it already, and it comes through. And there are protected paths. So the default that we are seeing, like, the conservative and both the aggressive and the conservative defaults has a lot of the right kind of excludes, like, don't clean out node modules and don't include .gits and so on. So it just comes through. And the enforcement point, like we spoke about, is actually the managed settings piece, right? Like, so the usual suspects like Terraform deploy and like, git push with force and so on. Like, and what is nuanced and interesting here is that it goes at an argument level. In a lot of customer scenarios, what we see is they have individual DevOps scripts where every argument matters so much. Like, you could have like a backup and restore script where if you do a small mistake in one of the parameters, you're going to be restoring from the backup and flushing the database and putting it in place versus doing the opposite, which you probably intended was the backup. And those kind of mistakes can be very expensive. And even running those scripts with an agent is just the way DevOps teams are also going towards today, right? Like, so having that trained on those manuals, or even having just like a small MD file that has like, hey, this is how you operate this, versus just doing -help, or like, just having a dump of the man page and so on. So, and you can do a lot of this automated, like, there are, what we do at Unbound is to just go over histories and say, hey, these are internal scripts and what do you want to do about it, sort of a thing. But it's the common ones like, git push and Terraform deploy, we are able to, like, it's pretty much up there, even within regular managed settings.json if you download it from Anthropic. So that is about the hooks enforcement itself, right? Like, so what we saw at the layer is the pause layer prior to execute. It is largely orchestrated by hooks, and any popular coding agent supports this today. This is GitHub Copilot, Gemini CLI, Codex, Cursor, including Claude. I think Cursor gets the credit for doing it the first. So there are a bunch of different ways that it happens, right? Like, so obviously at the prompt level, you have user prompt submit. This has been popular for DLP-centric use cases. So if you want to make sure your secrets are not going out as a part of the model context, you can make sure you're putting a hook on top of user prompt submit. Like a common one is to just do envs, .env files, any environment variables that is out there. Another could be anything. And you could even use like a truffle hog based detector, and there are OSS libraries that are out there. So it's almost like just the way you would do a commit hook. Before committing to Git, you would have a truffle hog detector. You could do the equivalent of it before it actually goes out to an LLM. So the risk here is not even that the LLM itself is not trusted. Sometimes it may not be, depending on which model you're using, but it's mostly about which MCPs you also have in context. So let's say this is now a part of your context variable, and then the next MCP call that you make is to say something like a context 7 or a playwright. And at that point, then you're also revealing the same secrets to those third-party untrusted MCPs. So that is why this user prompt submit and making sure secrets are not going out is usually a good practice. Not so much from the, oh yeah, I have a BAA with Anthropic or like, with OpenAI, so my data is not used for training or it's not going to be retained. It's really about the whole ecosystem. Do you have a TPRM with every single vendor that is added as an MCP becomes an important question to ask. So that's the first layer, right? And you want to be pretty lightweight about what you do on the user prompt submit hook, but a lot of the local processing with respect to secrets is generally a good idea because secrets are important in any way. The second one is a pre-tool use hook, and this, again, you can go, it's not about millisecond level latency that you need here because tool use actions are so far and few. I mean, like, okay, in the sense, compared to how often prompt submissions go back and forth. So if these are in the hundreds of thousands, these are probably, like, tool use is probably in like, somewhere between, like, say, the 5 to 10K kind of range, right? Like, so, and it does take a lot of latency between it identifying which tool to use, what's the MCP's definition, and, like, figuring out that I have to use the tool. So that's where the pre-tool use hooks comes in. So it's literally the POS layer that we were talking about. So is this aligned with what was asked for? Does this align with my organization's appetite for risk? Like, does this model with, is this some price checker MCP that is added because somebody thought it was a good idea to do so as a part of the context? So you can do a lot at the pre-tool use hook level. Like, you have full context, you kind of have bash access at the time of that being running as well. So you could even run additional commands to find out what's going on, what's the context, and what's the included MCPs at that time, and so on. And then there's execution, and then there's a feedback loop. There is another layer that we are seeing a little bit more common, and Claude made it more official recently as well. It's called a prompt hook, which is very similar to how auto mode operates in a way, right? Like, so instead of you having to write deterministic things, you just say, okay, use this prompt and evaluate this request against each of that prompt, right? Like, hey, does this tool use recognize my organization's policy about how AWS CLI needs to be used? Or are you trying to create the 100th Notion page today versus like the 50th Jira ticket today? The previous speaker was talking about AI now crowding, crowdsource vulnerability in hackathon projects. So it's just one of those things. Like, do you have the basic hygienes in place, and you can put a prompt also on it to support some of that. But again, like we said, the whole thing about non-deterministic enforcement is that you will always end up in a scenario where you don't have 100% coverage. And this is a paradigm that security practitioners are still grasping to get to because, hey, I have a firewall in place, I have my firewall policies and rules configured, now I'm like fully protected. And that's not the case anymore, even with all of these layers put in place, right? Like, so you can have these hooks in place, you can ensure that these are all running in a sandbox. But even then, there are layers that you will have where you cannot do protection. So again, then the best practices really come into place, right? Like, so always start from a branch when it comes to code, when it comes to data, make sure you always have like a replica, restrict access to production even more so from how it used to be before, and respect the pipelines where it used to be, right? Like, devs got a lot of leeway prior for bypassing pipelines. Like, sometimes even larger companies are suspect of this. Like, oh, yeah, hey, this is important enough to go through, and there are several copies of prod lying around wherever, production databases lying around wherever, and then now suddenly we have agentic access to all of them. So everything becomes like the usual security practices still help, and again, backups and getting through the process with commits and so on. So that really comes to the last piece, right, which is the user-centric part that we spoke about. Like, so this is, you can do everything that you want. At the end of the day, an employee is going to go click on the phishing email. That is kind of the user-centric part that I mean. Like, so every MCP that you add does add additional capability. Every skill that you add is also giving it more legs. So imagine an agent that has like 4,000 different legs and it can use any one of it to go do what you want to do. Then that becomes harder and harder to control. So you want to make sure, and it's also a context grab in a way. Like, if your 200K context window, which is how it used to be before, is getting like, 50K of it is all MCPs and skills that you've loaded, then what are you working with, right? Like, there's a lot of rot that can happen. So that is really where it comes to allowed MCP servers. This you can also do it on manage-settings.json, just very tightly sanction how MCP servers operate. Like, it's the same issue that we faced with SaaS back then. Everybody had their esoteric reasons of why they wanted to do something on, like, hey, this particular SaaS app is interesting. So something very similar, but still much more governable, because there needs to be a credible reason for somebody to operate something agentically. Like, oh, this thing on browser doesn't work, so I just want to do API to go sign contracts or something similar, right? Like, so, and you can slice and dice this by different user groups, by different people, like, levels of administrators that can do some of these things. Like, DevOps can run those sensitive scripts, but not cloud engineers, even like that level of distinction at that point. Again, the incident here is Postmac MCP, and it really, what I'll try to do was add a BCC layer at the time of one MCP coming out. And this is something that we see as a common trend, which is for every official MCP server that's out there, there are like 15 different clones. It's like being in an India bazaar in front of, trying to buy a Ray-Ban sunglass, right? Like, so that's what we see. There's just several variations of it. Anybody that has access to an API documentation can pretty much write an MCP server today. Like, that's just what we see. And some of them are literally malicious. Some of them get updated into something malicious a little bit later, but your MCP is still there at that point, and so on. So controlling that source very tightly really helps. There are actually only so few people that needs like MCP level access to pretty much a lot of these things, like maybe Google Workspace at best with only read and so on. So you can do a lot of granular controls over that, both programmatically and using tools if you wanted to. And the last is the user is still the largest loop, right? Like, so agentic overreach is one. Agents can go do whatever it wants to do. Config, supply chain is one part of what user does. The user can literally be like, oh yeah, I actually don't care. Here is my AWS secret key, go do it. And we've seen that in several hundred instances. Like, if we thought looking at PII was like, I'm finding thousands of it day in and day out, we have seen several instances where the developer is just like, or any user for that matter, just like, oh, I don't want to go put it in that console, give you a vaults ID or anything of that sort. Like, just Command V and here you go, just run with it, right? Like, so happens much more often than we give it credit for. The account swap is another that we have started seeing more commonly as organizations are putting a budget limit on how many tokens you can use per month. So, I mean, if you are an employee and a software engineer, you're paid well, you can afford a Cloud Max plan by yourself. So all they do is at the end of the day, just do a /logout and then do a /login back to their private plans, and they just start doing it. Like, I have a Max plan myself, and be like, oh yeah, I'm out of tokens now, so for the next 2 weeks, I'm just going to use this plan. So Anthropic came up with some protections around this, but there are lots of ways in which you can get around it today. And the worst thing is the skills, MCPs, the code base is all local, right? Like, so it's stored within your machine unless you're using like destructive sandboxes now and then. So that means the same personal plan is now able to connect all the way up to Cloudflare MCP, do whatever it wants to do on like a personal plan. So no protections whatsoever that is installed. And they also can see it if they wanted to. And last is hooks by itself can be a supply chain risk. And we're seeing more and more instances of hooks. So if you just are able to do an interrupt in every user prompt submit, that means like you are also placing a copy of what's going on with the user prompt to that whichever third party that you're putting into. And we are seeing an average users between 10 and 40 hooks installed in their machines in a lot of scenarios. And there are now clients that are coming up with their own hooks, like CMux or any of those wrappers of cloud or terminal wrappers that you use. It just has some of the localized hooks that makes a lot of these use cases possible for them. So I think it's becoming the next pillar, skills that hooks also needs to be audited at this point. So that's most of the content that I wanted to go through. And the last is the detect piece, right? So everything is non-deterministic, like we said. So what that also means is you are going to be putting in a lot of logs into your own system, right? So that just means, the joke on Splunk still remains. So you're just going to be logging even more of the actions at this point, and you just run LLMs through those list of actions to say, hey, what's going on in here? It is not preventive. It is going to be after the fact. It is in fact how Hugging Face detected its own set of events, right? So, hey, I have logged everything, and then you have an agentic crawler that is going and checking, hey, these set of events that happened all of yesterday, do they make sense or not? Did I get breached? Did I do something over? Is just an action that you can pass through if you have a record of all the events, which is and that's why it took so long to go through and get the analysis of what was happening as well. But I think there was also obviously implications around how they wanted to disclose it. So this is a starting checklist, right? I know we are also getting really at the time as well. So first is obviously inventory. You want to know what you're starting off with, what's your exposure looking like. And do turn on auto mode when it comes to preference. So it is actually pretty safe. Security community was initially a little terrified when they saw auto mode. They just thought of it as a extension of the YOLO mode or dangerously skip permission of how this came to. But it's much better than fatiguing people with 100 different alerts, which is just going to say yes to anyway. So it's just a slightly more LLM-centric variation of doing it. It'll cost a little bit more tokens, but it's relatively better. There are many third-party benchmarks around how auto mode is doing. And a good starting point is the settings.json relevant for sandboxes, and if you have the sandbox mode turned on. And you can ship policies via MDM to make sure that it's server managed. So the MDM ship policies also survive logout and login. So if you want to keep your managed settings very carefully chosen, and you want to put your session start hook to make sure that this is actually the plan and org that you want to be in, then the settings.json pushed via your jammer for MDM is actually a good reliable example. Pretty much everything else that we spoke about, make sure you have copies, make sure you have standing prohibition for specific deny rules. Again, you can never be so exhaustive with how large deny rules tend to be, and do record every single action and the transcript that's associated with it. It will be a lot of data and volume, but you can kind of choose policies around discarding it or flushing it as well after a period of time. Just that you want to be able to use agents to go through those actions to see if it makes sense or not, even if you're not able to do it live, because some of them actually make sense when you look back and pitch the pieces just together versus looking at it at that agent or the action level. So this is just a bit of references. This is the Anthropic's Cloud Code example settings that I was referring to. It's official, frequently updated also, so which is something that I like. A lot of the OSS repos, particularly of security, is relatively older, and these things are changing so often. So that's a good thing. There's OWASP Top 10, and also obviously the Simon Wilson as well. So I'll stop here for about 10 minutes of questions. This is the last slide, right? So just a little bit of where it leaves us, and that brings us to Unbound. So this is what we do at a product. So that's what we do at Unbound, which is discover, assess, and go all the way up to enforcement. I don't claim that we have solved agentic overreach, but we give you guardrails and controls that will prevent the blast radius if that happens at all. And we do have the slides online that is posted there, so the QR code has links to the slides as well. I'll stop for any questions if you have, and I'll be around after the session as well.
Raj, that was fantastic. Thank you. Managed settings. Managed settings for Cloud Code can be pushed by MDM, but do not require the organization to have a Teams account. Is that true?
Okay, great question. So managed settings does require a Teams or enterprise plan. That is something that you go and configure at Claude, the Claude's website itself. And the way it happens is when your Claude session loads, it actually tries to load those settings from the server side. So that's the managed settings, but you can do a proxy of it by putting settings.json through your MDM, and that is actually doable even if you are on personal max plans.
Or a config file.
Or
on Mac.
third party, yeah, if you're overriding Anthropic base URL, sorry.
And that will hold up.
Yes.
I don't know if you thought about this, but like for managed agents, like Cloud Managed Agent, how do you think this is going to evolve, like the pause layer? Because it's going to be like perhaps a dual pause layer, one on the vendor side, one on the sandbox side. I don't know if you thought about that.
Yeah, so we followed Cloud Managed Agents. So a way to solve for that is through the OTel endpoint, right? Like, so you have like a lot of what you're doing with managed agents is just going to be so autonomous that any kind of inline controls that you do is going to be less effective. There are two ways to get there. One is with managed agent, you have the good news of it being very purpose driven, right? Like you want the agent to do something relatively specific, not as broad as asking general purpose questions, going and troubleshooting any code. So you can do purpose-built credentials to it and give that access. That's number one. Yeah. And two is the OTel endpoints, the open telemetry endpoints, which Anthropic supports, work for managed agents also. So the logging piece and then having an agent crawl through everything that happened for the day and then coming back, that is a decent enough in-between solution. It's not the most ideal like hooks, but you have that.
Yeah, but the use case is different as well, because there will be long-running tasks where there's basically less oversight and
yeah, but the use case is not that different in the sense that you're still trying to solve for agentic overreach. You're still trying to solve for it not trying to hack a third-party website and making a felon in that manner, right? Like so, unless you're referring to a different kind of use case like token optimization, or is that the intended use?
Yeah, like very long-running processes like code migration that would run for weeks or months, or something like that. So with this, basically, what we have the agent harness locally is because we are interactive. As a developer, basically, because you're the orchestrator. But when you run managed agents, expect that thing to be started by the Jira process or anything. That thing would run for a week, and you would get reports like you was like an employee, getting once a week back to you and say, hey, this one happened like that. So it's basically, it gives another dimension to all these controls.
Correct. The issues there or risks there would be, one is agentic overreach, two is cost overruns because it is acting pretty much autonomously. Are the feedback loops tight enough for all the kind of interventions that you want to stop from? We have actually seen credible examples of people logging this in the backend separately and having more frequently running agents. Looking at, hey, is this making sense? Are the feedback loops making sense?
With dashboard, operator dashboard, those type of things. It could be asynchronous events and say, hey, is thinking about this? Do you think it's really the right direction?
Yes.
Oh, no, go back.
So I'm not sure if you used the Slack label feature that Anthropic has recently. No. So we've seen, and this is coming literally from Boris, right? Like he was talking about how they were running a long managed agent. All it did was it started writing its own blog series about the migration project that it's doing. And then it was just updating on Slack. Hey, this is what I started today. This is everything that I plan to do, and so on. And so it's not asking for authorization. It's just letting you know. And you can intervene and comment and change the feedback loop's direction if you wanted to. So there are more agentic controls around it. The same thing if you do logging of every single action in the prompt and tool use.
That's a good example. But like it shows like there's really a lot of work to be done, because for having full control, I mean, you need like some kind of an operated dashboard, something that
Yeah, more agentic way is how I see it as like
so
the dashboard.
It's just in infancy.
Correct, exactly.
Cool. Good. Thanks.
That's good. Thank you. Any other questions?
As a vendor, you're obligated to answer this question. When is it too soon to pick a pony as a vendor for these solutions, as opposed to waiting, building your own, until things have settled out? You know, this is such a fast space. There's going to be so many acquisitions and changes. How do those of us who need to solve this move forward without making bad choices?
Great question. I think a few things to look for with vendors in general, right? Like agility is a key thing that our buyers are now looking for. Like I was in product sometime, right? Like, so wherein you're like, my job was anytime a customer asks something, hey, yeah, it's coming 3 quarters out, and go show a roadmap slide and come out. Like, I'm not discrediting what I was doing, but the world has really moved on from that. So I think the agility is the key feature that buyers are now looking for. Like, hey, as these new problems come up, are you adapting quick enough to give me the solution? Because a lot of reasons why people come to vendors like us versus doing it on their own is also the same reason that you brought up. This landscape is changing so quick, and do I have like 2 people to just staff and make sure, like, you know, this is something that I keep following and updating my local solution, versus I trust my vendor to be on top of things and like, you know, when the new thing is coming, they're able to get to it or not. I think that's the key area to look for. Thank you.
All right, welcome everyone. Are we ready for our next talk, our panel talk? Woo! Just a short reminder to please keep your phone on silent as a respect to our participants. And if you have a question, please walk up to the microphone in the middle, okay? Without further ado, please welcome the CVE luminaries.
Hello, B-Sides. So, hi. We will go through introductions, heck, right now. Let's do it. Hi, I'm Todd. I am on the CVE board. I also work at a company to do things involving Yetis and dragons. It's pretty fun, and we will just kind of zoom down the line, say who we are, what we do. I used to work on Metasploit too, if that matters. And I will pass it to Katie. Katie.
Do you want a long intro or a short intro?
A 1 minute or less intro.
Oh, I can do 1 minute.
And while you all think of questions, and feel free to queue up, because guess what? This is all questions.
Oh, there we go. Now it's active. Hi, people over there. I'm Katie Noble. I work for a big tech company who I am not representing today. And so my so my opinions are my own. I sit on the CVE board. I was 15 years in the U.S. government, and I don't know. I've been part of the CVE board since 2017. So yeah, I think that's me in under a minute.
Does that take away from my minute?
No.
The fumbling.
It starts now.
Okay. Hi, my name is Lindsay Sturkovnik. I'm the Chief of Vulnerability Response and Coordination for CISA, which is the Cybersecurity and Infrastructure Security Agency. We like security so much, we put it in there twice. Have you used that joke? Did you ever use that joke? Yeah, exactly, yeah. And no one ever says it right, which is fun. So we just say CISA. Anyways, we do all kinds of things. We sponsor the CVE program. We participate as a CNA. We also run Coordinated Vulnerability Disclosure, or CVD, for the Department of Homeland Security and CISA. We maintain the Known Exploited Vulnerabilities Catalog and basically do all the prioritization and scoring for federal, civilian, executive branch agency vulnerability response. Do a bunch of other stuff, but all of it is acronyms that are very long, and I would love to talk to you about it afterwards, and you might see me later in the week. So over to you.
Thank you. My name is Jerry Gamblin. I work at Empirical Security during my day job. We create and maintain the EPSS system, so you might know that from the open source work that we do. I also run Rogo Labs, where my whole goal is to bring vulnerability data and information to the public in a couple of forms, CVE.ICU. I run the CVE forecast along with Aaron at First. Well, I'm not on the board. I spend a lot of time CVE adjacent and telling the board what I think they should fix because they need someone from the outside yelling at them.
It's always appreciated.
Nope.
You gotta switch it. Turn it on. You got this.
It's me. Can you hear me now?
Yes.
There we go. Hi, everybody. My name is Madison Ficarilli. I'm a staff manager at GitHub, where I manage the advisory database. So all of the vulnerability data behind things like Dependabot and NPM Audit come from my team. We also manage an open source CVE numbering authority, so we assign CVIDs to open source maintainers on GitHub. This year, we have published the most CVE numbers out of any CNA in history.
Congrats.
Ever.
Boo!
It's weird. I have conflicting feelings about it. So that is a lot to say. We review CVE data, we produce CVE data, we evaluate CVE data, and we do quite a lot with it from different perspectives.
All right, so that's everybody. The reason for doing that is not to waste time while people come in, though that is a handy side effect. It is to establish our bona fides as CVE experts. I think collectively, we five up here, mostly these four, we are concerned with millions of people, millions of devices, billions of devices, millions to billions lines of code, right? All of which has security vulnerabilities. I don't want to alarm anyone. Yeah, and so, and numbering and naming these things is hard. It's a lot harder than it seems. We've been at it for 26 years. It's 2026. 26 and change. It was like October of 1999 when it started. I think, unless I'm wrong. But who's counting? And so it is complicated, and it comes up in the news quite a bit. You might have seen some news not 2 days ago. Who heard about the SQLite bugs? Only some. Oh, good. Well, you're doing good conference work by not paying attention to the news. There was some drama, which follows the CVE program wherever we go, about some SQLite bugs that were submitted to MITRE as a CNA authority, and we can get into all that detail if you like. And it was like, oh, look at this, and it was JFrog, I think, was the research outfit that said like, hey, cool bugs, they're all fake and they're AI hallucinated. How did MITRE let this happen? And I will open. I think that you're all familiar with this, yeah? Yeah. I can open with this. Katie, how did MITRE let this happen?
Resourcing.
Yes.
Now, MITRE operates as a couple different functions for the CVE program. So our colleagues at MITRE, bless them, they run the infrastructure. So that means like the servers and that stuff. They also run the administrative secretariat function. So they schedule the meetings and they make sure that we stay on task as the CVE board, and they do the paperwork kind of administrative things. And the last thing that they do, which I should never say last because MITRE is fantastic, I'm not just saying that because I'm on a microphone. I really do like them. They run what's called the CNA of last resort, or a CNA of last resort. And that means that if there is not a CNA already assigned CVE numbering authority, so there's like 400 CVE numbering authorities these days. So like most big companies are CVE numbering authority. The intent being that they publish directly to the CVE database rather than, or the CVE list rather, because it's not database, rather than needing to go through an intermediary. So they're trusted individuals that have been, or trusted organizations that have been trained to publish directly to the CVE listing without any adjudication or anything else. So if, I don't actually know because I have not been following the news, but if MITRE published them, MITRE is operating as a CNA of last resort, which means they have a limited amount of staff who is responsible for going through these submissions. Their scope is to cover pretty much anything that is not covered by another organization's CNA. So if there's a vulnerability in a product that is for a company that is not a CNA, then that falls to MITRE to do. So you can imagine how much workload they have to do. They also handle things like disputes. If a CNA doesn't want to publish a vulnerability and a researcher says, no, this is legitimate, there's a dispute there. And the CNA has what's called last right of refusal. So they cannot refuse to publish a CVE entry. Well, they can refuse to publish it, but they cannot stop
block
it. They can't stop it. A MITRE would be the one that published that record instead of that CNA if the CNA says, I'm not going to publish this, I don't believe in it. So MITRE has quite a lot on their plate. They have a limited amount of staff, and they're not subject matter experts in literally every single company that is not a CNA. And let's face it, have we seen some of the outputs of AI these days? Because, I mean, we give it the like jokes about like how I'm fine because AI can't figure out how many fingers are on a human hand or how to spell strawberry. But some of this stuff's getting really convincing. And I know the company that I work for, we're spending a lot of time and effort and resources, which is a bigger problem I think Madison will probably talk about later, going through trying to sort the wheat from the chaff here, because AI has gotten so good that when we're running scans using Mythos or any other of the models, we're getting all of these false positives too. And it takes us about 60% of the work line of the workflow before we can effectively say, no, this is not real. So this is to be expected. This is normal course of business.
Go for it.
I have a much harder take and a much more bombastic take on this. This is a failure of the CVE program rules, and they know this. Between 5 to 8% of CVEs are put through the disputed process last year, I think is the number. There's nothing in the rules that say that you have to validate a vulnerability, is there, before publishing? So, like, they're just reading and saying, yep, I'm the last resort, nobody else wants this, I don't know, go, right? Like, and if everybody runs curl, go read the curl blogs for the last 6 years on CVEs, and he's had this fight over and over and over again that the data in the CVE records are not verified, and it's not claimed to be verified, and that's what MITRE will tell you, that they're just publishing records and that it's not, in air quotes, their job to go and verify that MySQL vulnerability actually existed, which makes you have to distrust the data by default, which as somebody who does data science around the edge is a terrible thing to walk into.
Jerry. I know it's cool to be incendiary. I get it. I do understand the frustration, but I want to go back and say there was a comment that you made that MITRE's not going through every record. They're just issuing CVEs. That's not true. That's not true. I understand if it can feel that way.
I thought that was the.
That is not.
I thought
they
that
do
was
review.
What they said,
have.
That they do not do a technical review.
They do some level of
Okay.
review. They may not validate it by running any sort of code, but
And
they
this might
do
be
some
a
level of
difference in,
like.
how we define validation.
Yeah,
too.
sure. They do some BS testing, if you will. CISA over here. They do some BS testing on what they get, but I think to Katie's point, like at least the submissions that we get for CVD at CISA And we used to have a caseload of like 250 to 300 at a given time, and now it's about 360 to 400 at a given time. So we're getting increased caseload, and the submissions that we get about 10 months ago, 8 to 10 months ago, were kind of crap, and we could tell like this is a bad AI submission. Now they're pretty like there are some very convincing submissions for CVD, and so I think to the point Katie made earlier, it is getting harder and harder to tell, and so I think agree with you and agree with Madison. There's probably a difference in definition of what validation is,
Yes.
but they don't just have a queue of 50
Yeah,
things that
and
they
sorry,
go, all 50, we're going to give you a CVE. There is some BS testing. It's
wasn't-
become more difficult.
Yeah,
It's okay.
because
It's
it's
okay.
always in the gray areas.
We're
I
all
wasn't
friends
saying
here.
they just push
Yeah.
everything. I am saying
It's my
that-
job to
yeah.
it's my job
Yeah.
to respond to that.
Madison, you got anything to throw in on this? If not, it's fine. If not, we'll have plenty of opportunity.
It's very hard to do at the scale that we're operating at.
Yeah.
The workload has increased 10 times over, whose capacity has increased 10 times over, and if it has, I'd love to talk to you about how you've done that. But, so the expectation is that, and I think where this is the difference in definition, the expectation is that you would go to a certain depth to get to a point of confirmation and validity. And depending on your experience, right, that might be reading this, and that might be enough for me to say, yeah, that is enough, this is real, or this is not. In the recent example, I mean, they went through some pretty deep levels of testing of the actual proofs of concept, right, and running code. I don't know how often folks are going through that level or depth of validation before assigning a CVE.
Mm-hmm.
It often depends on their scope and how much they have, but like for a CNA that operates at my scale, it would be extremely difficult, if not impossible, for me to run and verify a proof of concept for 7,000 plus CVEs. The amount of time and resourcing that takes is not negligible either. And so it's a balance of, is the delay worth that effort, and where does the onus or responsibility or agency lie? And so in this case, right, maybe the CNA that assigned these CVEs was erring on the side of speed. This is critical, we believe, and needs to get out quickly, did not have the time or resources to go to that depth for validation. Is it a bad thing that another organization who cared more and had that resourcing went through that level and got these rejected?
Exactly,
Is that
right?
bad?
Yeah.
This does, to me, the whole drama, which played out between, I think, Sunday through Tuesday, so kind of micro, does illustrate, like, this is the program at its most successful. It is, someone had CVEs for, a couple dozen vulnerabilities. Turns out they were, like, AI garbage. I don't think the person submitting them thought they were garbage. I think they were hoodwinked by their own tooling. Gave it to MITRE. MITRE says, yep, smells like a vulnerability to us, CVZ. JFrog and decided to test it and write extensive notes on their testing and said, like, no, these are garbage. And then MITRE said, cool, rejected. And so done and dusted in the space of like 2 or 3 days, right? Maybe that's not fast enough. Maybe you can't rely on JFrog volunteering those resources, but someone's got to. The reason for this panel is because how many people here were here last year for the CVE panel? That most of this was up. Almost nobody. A couple of nobodies. And and wait a minute. So last year we had a panel that was remarkably similar, slight differences in who exactly was on it, but most of the same people. And we went through and we yammered about CVE for 45 minutes. And then we were like, good job, everybody. High fives, we're out. And then some people got really mad at us about not having time for questions. And we're like, oh, dang, I didn't know the rules. I wasn't moderator, by the way, but I didn't know the rules. This was news to me that, like, there was a thing, but of course you do, right? Like, it's BSides, it's very community-oriented. And so the reason for this panel and the reason why it is entitled I Am CVE, Ask Me Anything, it is all questions. That little exchange we just had there is my question. We did not prep any of that. I hope it was unobvious. But if you have a question to ask of the CVE program, imagine yourself from BSides last year. Come on, get up here and show them how it's done. And we are anxious and eager to hear your questions from the community about CVE program, how it works, why it works the way it does, who's involved, the challenges, the wins would be nice, but I know y'all are security people, so you're going to just tell us how our babies are ugly, and that's fine. But yeah, we're here. We here for you here today. So, gentlemen, we've never met before.
Hi.
We have.
I know. We're good friends.
Yeah.
Hi, my name's Jonathan Leitschuh. I've been a security researcher for several years, and I have a lot of security researcher friends. And one of the common refrains that I hear from security researchers, so you were just talking about the case with CVs getting assigned when they shouldn't have been.
Sure.
There are plenty of stories where I've dealt with security researchers that have tried to get CVs assigned by MITRE or the CVE program and have basically gotten to a point where that doesn't work. And I've talked to quite a few security researchers who are just disillusioned by the CVE program to the point they're like, why would I even try to get a CVE number assigned given the amount of work and bureaucracy and fight that usually takes? Mm-hmm. It's just easier for me to write my blog post, publish it, and let someone else deal with it. So what would you say to a security researcher out there that has become disillusioned by the CVE program and the bureaucracy involved? And
Is that researcher in the room with us right now?
I don't know. I'm still willing to fight this fight. I am a glutton for punishment. So it's not me, but I do know that there have been people in this space. So I'm speaking for other people that I've spoken to a lot.
All right, cool. Quick straw poll elected me to answer this question. I would say that first off, as Katie mentioned, as we talked about just now, right? In many people's minds, MITRE is the source of CVE. In many people's minds, I go to MITRE if I find a vulnerability in software. First thing to do after, of course, I test it locally and I'm not hoodwinked by my own tooling, is go to MITRE and say, dearest MITRE, it's been a long winter. And I tell you about all my vulnerabilities, and then they're like, cool, here comes the CVE. This is accurate as of 2010, I'd say. So this is old news, right? But textbooks take a while to get reprinted. People don't know, right, that there are 400, I think it's 420, dude.
It's like 5.
It's 530. Jesus, there's been 100 just now.
The number surpassed MITRE years and years ago, like you said.
Yeah. So most CVEs are not published by MITRE these days. There are 519 other choices. They all have their own little scopes and everything. Most of these are vendor CVEs. You find a thing in Microsoft, you tell Microsoft. You find a thing in Oracle stuff, you tell Oracle, right? You find a thing in curl, you tell curl. Starting now, right? They're back from vacation, and and so that would be so. Now, it becomes an exercise in researching corporate governance sometimes to find out who makes this software, which sucks. So you can go, but you ask Alta Vista, who makes the software, or you can look it up in the CVE records, which are publicly available, and say have there ever been another one, and who issued that one? A lot of times you're going to see it's MITRE because of the history, right? But many times you will be able to find out rather quickly. CVE.org list of partners will tell you, for example. The website's, but you can. It is possible to find out. So that would be my first thing. Never, ever start with MITRE. MITRE is last resort. Yeah. And if you live in the U.S. and you think it has something to do with critical infrastructure, tell Lindsay, right? I'll tell you that right now, personally. Tell her. Yeah, no problem. What is CISA.gov/report, I think, or something. I think that's right. Still.
/CVD.
/CVD. Oh, good. So, okay.
Then you have to go through fewer wickets.
Okay, but yeah, it is a little complicated. But as you ended your question, more of a comment. Question is, well, why don't I just publish it and someone else will pick it up? Sure, do it. Whatever. There are CVE numbering authorities or CNAs who go and look for these things, right? Like Vulncheck is the one that I usually recommend people to go to for that kind of thing. Like, oh, there's something that is a vulnerability. Clearly, it's a vulnerability. I can see it in the release note. It says security all over it, like, but it doesn't have a CVE. Dearest Vulncheck, it's been a long winter. Please give me, like, and then you can get one pretty quickly through that until they get overwhelmed and they realize that this is far too expensive.
Can I take 60 seconds?
Please.
I want to add two after you.
Yeah. All right, Jerry, then Lindsay.
Talk about relationships here and
Sure.
how important they are. Like, I love your question. I get that question from researchers all the time that, hey, this stinks, like nobody's listening to me. But the reason we have 538 CNAs now is 530 of them are defensive CNAs, and it's for people like Daniel to be able to say, hey, researchers are publishing ridiculously bad CVEs through MITRE. I want to say in the process, and being a CNA is the way that they get to have a say in this. And I think that if researchers approach CNAs in good faith and CNAs approach researchers in good faith, we'd have a much better working relationship. It's not always that way, and because they're different sides, right? Like researchers want a blog post, and that's what CNAs say. They just want to get the press, and CNAs want secure software that also happens to fit their business cycles and their release cycles and their needs. So it takes a lot of time to get people together to understand both sides.
That incentive model and the differences in incentives,
Lindsay.
it's such an important. Oh, sorry. I like to look Jerry in the eyes. The incentive model and like describing it to, I know on my side at CISA, describing the incentive model to our executives so that they don't go, what? Researchers are doing what now? And saying, like, we have half a dozen things being disclosed that have gone through CVD at CISA here at DEF CON, and saying to them, you know, trying to explain to them the process of how those things went through coordinated vulnerability disclosure, and CISA was involved in some way, and yes, they are being presented at DEF CON, and it's gonna be okay. It's gonna be okay. Like, that's not a problem, right? I have to do that all the time. And so it's always an interesting thing. But the one thing I did want to add is, to the comment about like the experience of reporting to MITRE as a CNALR being sort of difficult. I'm being gentle.
We gotta work with these people, Jeff.
Right, like noted, heard, understood. We've been hearing it for a while, and there is an effort to improve the process slightly, right? So as much as we can on a short term, but providing more feedback on the status of the request is an important thing, I think, because it was something we were hearing a lot. It was like, it goes into a black hole. I never hear about it. So we're trying to improve that I guess experience of being a user of the CVE program or a participant in the CVE program in that way. So I did want to mention that. I think everything else that like Jerry and Todd said about going to CNAs and themselves and recognizing that MITRE is not your only option are still really valid. But the fact that you even complain about it is eye-opening for, I know this is a problem, but is good for me to continue to hear that this is a problem.
Well, it's useful. It's useful to hear it.
It's useful information for me and others who are in positions like me to help improve the program and the experience of participating in the program.
You, sir, in the Aloha shirt.
Why, thank you.
Yeah. Sure. We've got 20 minutes to go, so we'll do, certainly, yeah.
All right,
Thank you.
hopefully mine's easy.
Yeah.
Okay, so there's the CVE program, which is currently getting DOSed by AI crap.
Correct.
And so now we also have the KEV catalog with the CISA.
Correct.
So wouldn't over time those two catalogs kind of be the same catalog? We're pulling things out of the CVE catalog once they're disproven. Why do we have the KEV?
Great. TLDR, why KEV?
KEV is specifically for vulnerabilities that we know to have been exploited, that we have proof and evidence that they've been exploited, and technical artifacts to back up that exploitation. Philosophically, the KEV could become the CVE catalog someday if enough things are exploited. I don't see that happening anytime soon.
Prefer not.
No, but the KEV will grow. Just as the CVE program is growing, KEV's going to grow. So valid question. But there is a difference. We do down select from CVE. KEV is much smaller and more focused, targeted than the CVE, the large CVE database itself, or list itself.
Great. Sir.
Hi. So I have more of a comment than no, I don't.
Jesus Christ.
So, just kidding. So I have, like other people, have frustrations with the CVE program. I think everybody probably does at some level. And so I got involved many, many years ago. I've been working on multiple working groups, and one of the main things I'm frustrated about is the level of innovation, the change that happens. For example, SEMVer 2.0 came up a year and a half ago and is still not implemented or supported in the schema. So what I was wondering if you all could just go down the line and just say, what do you guys hope is going to happen over the next year? And more on that. Just something that, you know, what
So what will happen in the next year in CVE that we are hoping
you
for?
You want to see good happen and
hoping
change.
/ working towards.
Yes.
Got it. Let's go reverse order. Madison.
I would like to see a working user registry within the next year. User registry, yeah. So a working registry that captures all of CNAs. So not those requesting CVEs, but captures all information about CNAs. So maybe I, as a fellow CNA, could eventually do something like programmatically determine scope conflicts, which is my dream.
Yes. Jared.
CVE record data verification and validation.
Okay. No, that's fine.
I mean,
you know.
We need to, yeah.
We want to be fast. There is an API, and like it is possible to write bad CVEs that get rejected. It's also possible to write bad CVEs that
don't get rejected.
That
yes.
pass technically, but have no actual data in them. Yes.
I would like to see infrastructure and tooling modernization. It's a
Yes.
big priority for me. We've been hearing about it for a long time. With the increase in AI-enabled vulnerability research and discovery, I think it's well past time that we see some infrastructure modernization.
I have two.
You have two, Kate. Okay.
So
All right.
quickly, I would like to see the program modernize in the form of additional funding streams and increase international participation on things like the board. And then second, I would like to set up my kangaroo court, which I've been trying to do for years now, to deal with all of the disputed vulnerabilities that are still disputed and have been disputed for years now.
Yes, there is a crust of disputed CVEs that will never go away until we deal with them. Thank you. Oh, how about me? I want to simplify JSON. I think it's ridiculous that it has hundreds and hundreds of elements. How many elements is it, Jerry?
527.
527 exactly.
Visit CNAscorecard.org for all your CNA scorecard.
Yes, thank you.
needs.
Yeah, I think it's ridiculous that it's so big. I think GCVE went down the path of a very slim JSON and then found very quickly it's like, oh no, we need more, and that just just stinks of software cruft. But I would like a JSON Lite version, so I can write a normal CVE in a normal way with a computer. Yes, sir. We've never met before, even though we have the same shirt on.
Adam. So, broad question for everybody. You know, CISA's lost like 2,500 resources last year in terms of jobs. Their budget was cut, I think, around $700 million for the next year. So my question to the panel is, what do we see as the very real consequences, realistic consequences of that? Without getting into the politics, just what are the real world consequences? And what does that mean for us in the industry broader for that?
So the question is, CISA lost a bunch of people over the last, year and a half or so. What does that mean for CVE? I think we can scope it that way.
Sure.
Yeah.
I'm happy to answer that. I mean, the first thing I will say is my team remains. We are still here. We are still working on the CVE mission. We are still working on the vulnerability response and coordination mission for the federal civilian executive branch agencies. We prioritize and triage, every year the thousands of vulnerabilities, right? So we still do our work. The mission remains. We are very focused on it. It is difficult. I would not even pretend to say that losing that many resources is not difficult. And anybody who says otherwise hasn't been around for a while. But I would say we are hiring. We are trying to increase our numbers again in order to sort of build up from where we were, where we lost resources. And so that's one of our biggest challenges on the horizon is hiring. The CVE program has never not been a priority for CISA. My acting director, Nick Anderson, was on stage at Black Hat yesterday saying the same thing about vulnerability management. He is very interested in the CVE program and regularly asks me how it's going. And so all I can say is that it is a priority for the agency, it is a priority for the department, and therefore it's a priority for the administration that the CVE program continues to run healthily.
Dope.
First of all, thank you for doing this panel and being so open and transparent. My question is there any truth to the rumor that CISA intends to dismiss the CVE board regardless of what happens to the CVE bill?
The question is, thank you for being rad. Is CISA going to dismiss the CVE board?
I have no plans myself to make any announcements this week, so thank you. I'm happy to talk about the legislation, which has some advantages and disadvantages. In particular, I think codifying CVE in legislation could be a very good thing, and I hope others agree. Certainly ensuring that, you know, from the CISA perspective, like, we like the idea that CISA would retain some sort of codified role in the CVE program going forward. It would make it a little bit easier to advocate for CVE. There are some things that I find very restrictive about the bill, including the language about the composition of the board. And it's restrictive in both directions. Like, if me, myself, this is not how this happens, but if I wanted to dismiss the board, the bill makes that difficult. If I wanted to retain the board, the bill makes that difficult. And so I think there are some things about that bill's language that are overly restrictive on how anyone could or should run the CVE program.
Anything? So, and I did a fair amount of research on this chunk of legislation, which is, it last appeared as an amendment to the National Defense Authorization Act. It is not in the current National Defense Authorization Act. It is unlikely, according to reports, to make it back in. There was a big kerfuffle in the Rules Committee at the House. This is not a government policy talk, but it seems unlikely. So legislation exists in a amendment form that currently seems to me, anyway, a little homeless. It'll probably come back next year. So if you care about such things, write to your representative. And they actually do want to hear from you, you know, especially the ones that are on like cybersecurity committees in DHS and all that, because they don't magically know how the CVE program works. You know, I am imagining some people are learning some things today, right, about the CVE program. Now imagine you didn't come to BSides, and also you have 1,000 other competing priorities. So, but if this kind of thing is important to you on the legislative congressional side, and if you're in the U.S., write to your representative. If you're a U.S. citizen, if you're not a U.S. citizen, write to your favorite representative. Like, whatever. Like,
Their email addresses are public.
Their email addresses are public, and they do read them. They must.
Hi. Open-ended, and I'm hoping more positive question, primarily at CISA. But
oh God.
Take this as you will. But what does good look like for the CVE program with respect to timeliness, validation, whatever?
Sure, that's a good question.
I think that's a good question for everyone.
I'll answer, but I also would like
but CISA first, because that's the one I care about.
Okay.
I want to hear everybody else's.
So the question is, what does good look like in the CVE program? CISA, go.
There's a couple of things I'll say off the top of my head, which I think there are lots of other things also, but these are two that are really important to me. The first is I would like the CVE, I love this word, I would like the CVE program to be a little bit more nimble and flexible. That's the first thing. The second thing is responsiveness. I have, since sort of taking over some of the CVE program responsibilities, it has become a priority of mine that we are more responsive. And I say we because it's like something that needs to be set from, you know, as a priority for the CNA-LRs and also for other CNAs, right? So like Jonathan mentioned, working with other CNAs needs to be quick and fairly lightweight also. So that's something that I would like to build that responsiveness more into the philosophy and ethos of the program as we sort of move through the next couple of years.
Can I go next?
Please.
So I do take a little umbrage with that question, not with Lindsay, because Lindsay's great, but with this perception that CISA is the CVE program. CISA is not the CVE program. CISA funds the CVE program. The CNAs are the CVE program, and the community is the CVE program. So CISA publishes some CVEs. Congratulations, fantastic work. I love your work. I used to do your work. So when I hear this and it's directed purely at CISA, I would ask people to go and take a look at the setup of the CVE program, because those 500 CNAs are doing the majority, way more work than anyone else. It's the working groups who are hosted through MITRE operating in the conditions for which I explained earlier, and then the CNAs. So it is a public good that is a community-driven program. It is not a government organization. So I take a little offense when people are directing all of the administrative questions at CISA. CISA is a part. CISA is not the whole.
I don't see him. Jerry, yeah.
I would like them to enforce their rules uniformly and as written. That would be that would make my day.
That would be good.
That's what good looks like.
That's what good looks like.
Good is like following the rules you have written down and said everybody should
yeah.
go, like not having.
I would go so far as to say, in general,
yeah,
rule following is fun. Madison, I'm positive your experience at GitHub gives you some unique insight to this.
Yes. From my perspective, what would make a good CVE program is, I think, the right resourcing, capabilities, and automation in place to really allow the program to scale in the way that it very clearly has to in this day and age. I think that we are all together making it work because we're a community who cares too much to give up. But I do think there is a lot of progress to be made to make things easier to work at the scale that seems to be the way that things are going. So I'd like to see a lot more automation, and so I think that would also then contribute to things like better validation, timeliness, more responsiveness, easier communication among CNAs. Like, I'd love to do better scope deconflicting, because I have a gigantic scope. It's almost everything on GitHub, so it's a big problem for me. But so I'd like to see more. I think good would be supporting where the program is in reality, and I think we're a little behind at the moment.
Mm-hmm.
Thank you. Sir.
Hey, I'm going to ask a lot of questions out of ignorance. So
Okay.
Please help clarify.
Tell you what, you can ask a question, and
okay,
then
so
circle back
just
around.
in case anyone wants to know, it's Amendment 812 to HR 8800
Correct.
for the NDAA that
Yes.
you can look up. It feels like, okay, so that dropped in April, right?
Correct.
Okay. You were assigned on the board as a temporary voting member in, what, a month ago? Or something like that? You?
Me?
Are you
Okay.
on? Yeah. Is that a conflict of interest for a government agency to be trying to take a controlling stake over a community and global resource?
Well, CISA's been on the board for years, number one. Is that what you were?
CISA's on the board. Yeah, CISA has been. People at CISA have been on the board for years. I used to work at CISA. I was on the board. There's 2 other CISA employees who are also on the board.
I would
currently.
Can I take 30 seconds to complain about the board?
Sure.
Just because.
But let's let Lindsay finish.
Sorry. I thought she was.
No, I was just going to say CISA's been on the board for many years. In the way that the board is defined right now, we all have ethics. We go through ethics review in order to participate in the CVE board. So I think that's taken care of by that. Fair question, I think, but it's maybe a misunderstanding of how the board itself functions.
Can I jump in before Jerry?
Before Jerry,
Yeah,
yes,
just
fine.
Just to say that, like, we asked for CISA to send a representative. The board asked for CISA to send a representative because the way the board is currently comprised, there are traditional members which are appointed, go through an interview process and are appointed, and those members, historically speaking, and I am guilty, I was the CVE sponsor, and I was interviewed to participate in the board, was assigned a board seat. I sit on the board, have sat there since 2017 when I was the government CISA representative who ran the program. So there are 3 CISA representatives. There are like 8 government employees, by the way, on the board. So
U.S. government.
U.S. government employees. So those positions are assigned to the individual, not to the organization, which is inappropriate in my opinion, because government or government employees change positions. And so that means that those people who are still on the board are in different roles now and maybe are representing the CVE program, maybe not. Maybe they're doing other things. And so it is more appropriate to have a person who, like Lindsay, who is the program manager of the CVE program, to be the person sitting in the board as a liaison position. And if she were to transfer to another position or be promoted, then that position would go to someone else and not be retained with her.
The CVE board is not a board in any sense that anybody would recognize. The members are self-elected with no time limit. So once you're on the board, you're on the board forever. They had a power struggle. Everybody knows about this, but like when we say the CVE board, it's not like HOAs have to have more structured boards than the CVE does. So like you can't be the vice president for your HOA for 3 years, but you can sit on the
vice president.
You can
we have no president.
You can sit on the CVE board for 20 years and not represent anybody. It's not just the people from the government. If you see someone from Microsoft on the CVE board, they're not they're not representing Microsoft on the CVE board. They're representing their own personal opinion. So
Their own experience.
So it's a board of 20 plus people who aren't ever rotated off and aren't representing their companies. So like
As appropriate.
I am a big proponent of pushing it off. So like I think Microsoft, Google, GitHub should have a seat at the table as those companies and say, hey,
Sure.
I'm Microsoft, I drop 700 CVEs, I should have a say in how this program is ran.
I love your HOA comment. And
I also love the HOA comment, Jerry. Have you been just sitting on this?
I know, right?
Okay, this is great. Yeah, I think of the people up here, I believe Madison is the babyest CVE. No, Lindsay is.
I'm the baby.
You're the babyest now.
But I'm a liaison.
Yeah, you're a liaison, so you barely count. And I am,
I only joined the board like
vice
2
chancellor
years
for life over here. Yeah, no, it's a real problem. I will say that, thank you. I will say that the NDAA amendment addresses that component head on with term limits, when people can get fired, when people rotate out. It's kind of complicated and long. But yeah, as the gentleman mentioned, it's HR 812 NDAA if you want to look it up. We have 2 minutes left apparently, so knife fight and whoever wins gets to answer the question. Okay.
Thank
Valorious.
you, everyone.
Yeah.
Quick, so CVSS score does help, EPSS score does help. My question is there a CVE listing by search engine score?
Oh, are you a plant? The question was, CVEs have CVSSs, EPSSs. Is there like a list by score, Jerry?
Yes, the CVE.org program spent some time this past year rewriting their search, so you can actually go and search on the website. Just go CVSS, greater than 6.0, and it'll list all the. But
We are.
By search engine.
Uh-huh.
So like Google, which CVE highest?
Oh, yep. EPSS does that. The EPSS website is perfect for that. Yep.
Yeah, so yeah, a stack ranking EPSS will do, right? There are many ways to score vulnerabilities by riskiness and vulniness and threadiness and all that. I've written some papers on the subject. Go look them up. But yes, but this is all part and parcel of like, we want the CVE program to be better. We want the website, the assets to be better. We want it to be able to answer easy questions like that.
But I will remind you that the role of the CVE program is not to score anything.
Correct.
Or to assign patches. It is to identify and catalog vulnerabilities.
Yes.
It is not to score things. So if you're looking for scoring, CVE program is not the appropriate place for that. Enrichment,
Yes, and this will be
information belongs somewhere else.
And this is, I'm sure, very surprising to everyone. Do you have a question I can answer in 5 seconds?
I have a question Jerry can answer.
Okay.
Jerry, I would love your hot take. I was looking at the CNA's scorecards. There's some vendors that are way at the bottom, and they seem to misbehave, and they don't like to give any extra details. That would include Apple and Mozilla.
Uh-huh.
What's your take? Should we force them to behave?
What's your take?
I mean, I wrote the CNA scorecard to be non-judgmental. It could have been a lot more judgmental. It just counts what data they put in the fields. It doesn't score the fields. It just says, hey, do you tell me how to patch this? Do you tell me, do you give me a version so I know what it is? And those that are on the bottom don't, and they know. And I before I launched it 2 years ago, I went and talked to as many CNAs as I could, and some of them said, yeah, we're not doing it. But I will say, like, Microsoft didn't have the patch on there, so they weren't on the top. And Lisa was like, oh, I didn't even know that was on there. So they made a change at MSRC where they include the patch reference on every CVE now. So now they're back to 100%. So like I'm not trying to shame people because I don't think that works, but I think like you have to be honest and you have to shine the light, like an open government thing, right? Like it's not to shame anybody, just to tell people what's going on.
Sometimes they don't know.
Yeah, sometimes they don't know. You don't know.
Right.
Yeah.
Sometimes they do know, and they're
Sometimes
just
they
doing
do
all.
know.
I'm sorry, I'm all out of carrots, guys. I have
sometimes they
no
do.
carrots.
Yes.
I only have sticks. So
Yeah.
I'm all about let's hold these people responsible for doing their job.
I'm
'cause
fresh
you're
out of carrots.
the list for everyone else.
Well, hey, thank you so much, B-Sides. I will give you an action item because I'm dressed like a manager. And that is there are several CVE working groups that are also very unlike working groups you would find anywhere else. Don't worry, it's not limited to just the board. But many of them are open to the public. Most of them are open to the public. You don't have to be a CNA. You don't have to ask permission. You can just show up to the meetings. If you just, ask Jeeves for CVE working groups, you will get a list. And so, like, I run the CNA, the CVE Numbering Authority Organization of Peers, which is shortened to COOP. Jerry's on the Quality and Consumer Working Group and Automation Working Group because he has nothing else to do. HOA-ness again. Madison floats around some.
I hang out in the automation working group
Yeah.
primarily.
Lindsay, we'd love to have you in a working group.
I got a lot of time.
But yeah, so this is an avenue on the week to week, right, to feedback outside from writing to your congressperson. And with that, I would love to thank my panelists. Thank you so much for being transparent, being honest, being vulnerable, and hopefully answering some questions. Thank you all, and have a great rest of your week. Hooray, Vegas.